Now, you came across a question like this in your forthcoming jam or in any exams per se, and you came across a question like this that says, how many atoms are present in 6.0 grams of magnesium, given magnesium as 24 and A as 6.02 times 10 to the power 23 mole. Now we're given the options as A 1.20 times 10 to the power 22, B 2.4 times 10 raised to the power 22, C 3.02 times 10 raised to the power 22, D 1.51 times 10 to the power 22. First of all, you need to understand the question. Now, what area of chemistry is this? Now, there's an area in chemistry or a branch in chemistry called stoichiometry. It is called stoichiometry. Okay, that's I here metry. Now, what is stoichiometry? Stoichiometry is the branch of chemistry, okay, that relates the quantitative relationship, or that talks about the quantitative relationship between what reactants and what their products in a chemical reaction. Okay, and now there's a particular postulate that supports that. That's the law of mass that states that what matter cannot neither be created nor destroyed in a chemical reaction. Okay, so this is a branch of chemistry. Whenever I say a question that is in this form, it's talking about what stoichiometry. Okay, and that's that will lead me to creating a content on balancing of chemical equation. In my next video, I'll make a video on what balancing of equations. Okay, so let's go further to the question. So how many atoms are present? This is how many atoms are present in 6.0 grams of what magnesium given. Now this mg here given to us as 24 is what the atomic what we're going to take. Let's write solution and get the data given. Okay, so our data given is what the atomic number of what of magnesium. Atomic number is what's given as 24. Okay, and we have this Na. It's otherwise called what the Avogadro's constant. Okay, or number Avogadro's constant. Okay, it's given as 6.02 times 10 to the power 23. Now, what is Avogadro's constant or number? Avogadro's constant or number is the number of what atoms, molecules, or particles in 1 mole of substance. For instance, I can say water H2O, okay, contains 1 mole of what substance. That's Avogadro's constant. It contains what 6.02 times 10 to the power 23 what Avogadro's constant. Okay, and also what were we given here as well? Okay, nothing. Now we're looking for the atoms. Okay, we're looking for the atoms of magnesium. That's what we're looking at for. Okay, that is how many atoms are present in the 6.0 grams of what. Now looking at this, we already know that the mass given to us of magnesium is what 6.0 grams. Okay, do you understand it now? And the atomic number is what 24, or the molar. We've gotten our data or the given data here. So what do? We proceed to solve the question. Permits me to clean the board. What atoms present in 6 grams of what magnesium. Now to calculate this, we know that moles, that was otherwise we're looking for the moles, is equal to what mass over molar mass. Okay, now for us to get our moles, so we can calculate how many atoms are present in what 6.0 grams of what magnesium, we need to calculate first what the moles present. Now the mass of magnesium given to us here is what 6.0 grams. So our moles therefore is equal to what 6.0 over what's our molar mass given what 24, otherwise the atomic number as well. So we have 24, right? So let's solve 6.0 divided by 24 will give us 0.25. But this is not what our answer, because we're looking for how many atoms are present in what 6.0 grams of what magnesium. And I said Avogadro's constant is given to us here already as what 6.02 times 10 to the power what 23. And what is Avogadro's constant? It simply means what? The number of what? Atoms. The number of atoms, okay, and molecules and what? Particles in one substance, what? In one mole of a substance. You understand? So we have 0.25 now. So what do we do next to get our number of atoms? We go further to say what? Number of atoms. That's what we're going to calculate for number of atoms. Number of atoms is what? Is equal to what? Let me use this part of the board. It's given as what? So let me use it. Number of atoms is equal to what? Moles times what? Avogadro's constant. Avogadro's constant. So what is our moles obtained from this question? So we have what? 0.25. Okay, so 0.25. What is Avogadro's constant given to us as 6.02 times 10 to the power 23. So 6.02 times 10 to the power 23. So let's calculate and see what it's going to give to us. 6.02 times 10, 0.25 times 6.02, okay, to the power 23. It gave us, is equal to what? 1.505 times 10 raised to the power 23. So the number of atoms now present in 6.0 grams of magnesium is what? 1.505 times 10 to the power 23. And also, if you're solving the question in any exam, if the answer is not close to it, you can approximate to the what? Nearest what? Significant. You can round off to what? To the nearest significant. Now we have here the options given to us as what? 1.20 times 10 raised to the power 22, 2.4 times 10 raised to the power 22, 3.02 times 10 raised to the power 22, 1.51 times 10. So which of these options is actually close to this answer here? So we have what? We can now round it off, okay, to what? 1.5, this one here, 1 times 10 raised to the power what? 22. Take note, as you're rounding off, this power what we reduce. That will take us to another area in mathematics, maybe rounding off of number to the nearest significant or to the what? Nearest whole number. So this is the correct what? Answer to the question. And I promise, I said I was going to make in my next video, I'm going to make a video on balancing of what? Chemical equations, where you balance what? The number of reactants and also the what? Number of products gotten in a chemical reaction. Thank you for watching. Please do well to comment and also what? Share. I'm going to leave one question with you. And I'm going to leave one homework with you. I would want you to tell me the area in chemistry or biology where you want me to explain more or throw more light, or you want me to expand to you for a better understanding. Thank you and bye for now.